This is an ABC podcast.
So, on a scale of 22-ton rockets plummeting to Earth to hopefully eradicate all humans, how are we feeling today?
Pretty good.
Hello from the children of planet Earth.
Hey, I'm Gourmet astronomer Carly Noon.
And I'm deadly Camilla scientist Corey Tutt.
And this is Cosmic Vertigo.
The show that takes a down-to-earth and deadly look at all the sparkly
And the not so sparkly.
stuff in the sky.
Today, a mystery of astronomical proportions. A lonely night, a strange signal. But who was the culprit?
Ooh. Was it One Direction using Morse code to get back together finally?
Maybe it was aliens.
Oh, not again. It's always bloody aliens.
New cosmic episode coming right now.
Catch.
Okay, Corey, I have a story for you.
Yep.
Imagine this. Picture you are an astronomer and you're searching the skies, looking, just looking out, trying to find some sign of anything. And suddenly you detect this really loud, really bright signal. And as soon as you see it, it's gone. It's like a flash. It's like a flash of lightning, but in radio waves. It looks familiar. It looks like something that, we've kind of seen before, but it's not the same. It's different. There's something going on here.
So it's not like Wheatus Teenage Dirtbag being broadcasted out of space. It's something different.
Yeah, no, it's not quite decipherable like that, to that level. It's not early 2000s smash hit, but it's just this really loud bang. Now, people have been thinking, is it aliens? Is it anything that we don't know? It's immediately aliens, understandably. But look, there have been many of these signals detected. They've been kind of related to these other phenomena called fast radio bursts. Now, fast radio bursts, we have no idea what they are, but this similar type of signal that we've been receiving, the funny thing is, we only receive it at 2 observatories on the planet. Only 2 observatories are getting this signal. No one else can see it. One of those observatories is, of course, the fabulous Marianne, the Parkes Radio Telescope in, of course, Parkes, New South Wales. And the other one is in Switzerland. So what do you think is happening here? Is it real? Is it aliens?
Well, I mean, if 2 places are getting that signal at the same time, it's generally pretty real. Or some kids playing Teenage Dirtbag and it's the Martians are loving it and it's being beamed back to us kind of like a big mirror.
Sure. Well, I have some light that I can shed on this signal. Now, this is one of my favourite stories in astronomy because it's so silly. So, for 17 years, we were getting these signals at Parkes, at Marianne. We had no idea what was happening. The signal was about 1.4 gigahertz, which is literally the exact same frequency of radio waves that we know are everywhere in our universe. But it only lasted really briefly. And the funny thing is, it only occurred during office hours and it mostly occurred on the weekdays. So again, some further evidence to suggest this is not coming from space, that this is actually originates on Earth. Now, an incredible astronomer, Emily Petrov, she's an Australian astronomer.
She's got an awesome last name.
Yeah, she's incredible. Hey, she's actually such a huge inspiration to me, and I'm sure many other women in astronomy, especially in the radio scene, because she ended this 17-year mystery as a student as well, I should add. She was a student at the time, and she discovered that the origin of these signals were actually microwaves.
Oh my God.
Yes, like the microwave we use to heat our food.
So the microwave that I used to reheat the pizza I had for breakfast this morning was the same microwave that was sending these mixed signals to these radio telescopes in Parkes and Switzerland.
Yeah, so you would think that we would have, some controls over things like this. But the key piece of information that, kind of closed up this 17-year-old mystery was the act of how people use the microwave. So let me ask you, when you put your pizza in, or, your old coffee that you've left there, and you put it in, you put the timer on, do you let it finish its timer? Or do you hastily open the door before the time is up?
I hastily open the door before the time is up.
Yeah.
Because I like a chance.
Yeah, you and a lot of other people. That was exactly what was happening at Parkes. People were opening the microwave door before the buzzer had gone off. And what happened was basically there was just this huge dump of radio waves when people were opening the door. This was happening at a Switzerland observatory as well. Exact same situation, people opening the door. And because when you open that door, that microwave, it loses the shielding and all of those waves can just kind of pour out of the door. Well, I have some light that I can shed on this signal. So it was called a periton signal, and it was named after the mythological creature, which is a half stag, half bird creature. We now know very well what a periton signal looks like. We know that it comes from here on Earth and our technology, of course. It's not like we don't have enough interference already. But yeah, I absolutely love this story. I think it's hilarious because this signal was taken seriously for many, many years. It threw such a huge spanner in the works in terms of people questioning whether fast radio bursts in general could be coming from Earth. Maybe they're different types of microwaves or some other type of interference that we don't really know of.
Well, the saying goes, every action has a consequence.
Yes, our beloved Newton, every action has an equal and opposite reaction. We love our three laws. But in the recent years, we've been able to detect many, many more fast radio bursts. We know that these are, not uncommon now that we have incredible technologies to be able to detect them. And we're pretty convinced that they are not coming from Earth. In fact, a lot of science has been put into proving that they have origins outside of our solar system, most of the time outside of our galaxy. A bit more about fast radio bursts, or the FRBs.
Yes, please.
Well, their names pretty much tell it like it is. Fast radio bursts are radio emissions that come from the distant reaches of our universe. And they're really short-lived, lasting for about a millisecond.
Blink and you'll miss it.
There are a lot of theories about where they come from. It could be signals travelling from neutron stars and even colliding galaxies far away. But because they're so quick and short-lived, finding them requires a lot of interstellar detective work. Fast radio bursts were probably one of the first things that I was kind of introduced to in the radio world. Funnily enough, observing the universe in radio is really not much different to observing it in the optical. We just get a little bit more detail, and we can also see different things like these fast radio bursts. Now, when I was first starting, my astronomy degree, it was about 2016. And this was a time when fast radio bursts were the coolest thing. We still don't know what they are. And there was a lot of buzz around them, potentially being alien civilizations, sending out huge signals. Today, we're a little bit less certain on that. There's not too much talk about it being aliens anymore, but we're still not really sure what they are. But what I find really interesting about this field is what fast radio bursts have helped us understand. Now, a team of Australian scientists led by Jean-Pierre Macquart, they were able to locate about half of the missing matter in the universe using fast radio bursts. Now, this is really recent science, whether we're looking for normal matter, which we call baryonic matter, which is the stuff that makes up everything we can see. So, I'm made out of baryonic matter, so are you, so is our planet and our stars and our galaxies.
I don't know. I think I'm partially made out of M&Ms because in the studio, someone has M&Ms and I've been smashing them. And I think it's so important that all studios contain M&Ms.
You are what you eat. I'm really excited about this because these were literally the things that got me into radio astronomy. So essentially, this research team, they saw an FRB signal, fast radio burst. They determined how far away it was using optical astronomy. And then what they did a few calculations, and they could determine how much matter that FRB signal had to travel through, or how much it did travel through before it reached us. And from that, these scientists were able to infer how much matter is actually in our universe and how much we can't actually see. So there's only a small fraction that is visible to us. When we're talking about baryonic matter, this is about an estimated 5% of the universe. Before this study, and this came out really recently, before this, we could only observe about 2.5% of the universe. So only about half of the baryonic matter. So we knew there was another 2.5% that was out there. We just couldn't detect it. But this study was able to use these really cool signals. Even though we have no idea what they are, we were still able to use them to understand something really fundamental about our universe. And I think this is just such a great example of the type of science we do in astronomy and the ways in which we go about understanding what we're seeing.
Cosmic Vertigo is brought to you by me, part-time volunteer Taylor Lautner lookalike.
And me, Carly Noon. This season is produced by Ivy Shee.
Joel Werner is the executive producer and all-round best friend of the show.
So it turns out the answer to the mystery was the hungry astronomer in the observatory with the microwave.
If you've got the munchies and you're hungry to hear more, leave us a deadly review and tell your friends and your enemies about the show.
But for now, that's it from us. See you soon.
Later.
You've been listening to an ABC podcast. Discover more great ABC podcasts, live radio, and exclusives on the ABC Listen app.